this one's not rolling. Here we go. Let's do some experiments. Get a little base added on the right. See some beautiful color changes. See if we can get this to blue. Nice. A little bit more. Trying to get let's get some blue and orange colors, shall we? Maybe we'll try to channel some positive energy for the Tigers. Playing the Cleveland Indians right now. That's a tight game, man. I couldn't handle watching anymore. I was too nervous. That looks violet to me. Let's back it off with a little bit of acid, just a bit. There we go. Cool. Yeah, I got some blue and orange going there. Go Tigers. Go Detroit Tigers. I couldn't stand watching the game anymore. I'm too nervous. Too nervous. All right, here we go. Sorry about that. I lost connection there for a second. So what I got here in the two flasks, I have some water. I've got some universal indicator. And you can see the different colors that universal indicator will display at different pH values right here. So you can see this flask over here. What's that, like pH 4? Yeah, it's orange. Over here, it's blue. At pH, I'm going to call that 8 or 9. And watch what happens over here on the left. Oh, we'll do it on the right. You can see up here at the right, I'm going to be adding some hydrochloric acid, the same acid that's found in your stomach. And when I add drops of that, you see the color shifted from a blue to kind of like a green. So you see addition of acid causes the pH to drop. And that's consistent with what we chemists know about. pH. As the pH is lowered, the acidity increases. I'm continuing to add acid. You can see me adding drops up here. Looks like we're down to about pH 6. Here, we're going to do this over on the other side. I'm going to add some base over to the other side. The base I'm adding is sodium hydroxide. We'll add a few drops of base over here. 1, 2, 3. Yeah, it looks like they're both roughly pH 6 or 7. Add another drop of base over here. Another drop of base on the left. Hey, we got them pretty much at the same pH, yeah? pH 6 or 7, somewhere in there. Now we'll see it simultaneously. So on the flask, on the right over here, I'm going to add hydrochloric acid. It's the same acid that's found in your stomach. And on the left, I'm going to add sodium hydroxide. So here we go. Let's add a drop of each. So there goes the base. There goes the acid. All right, let's go like 3 drops of base. 1, 2, 3. We'll go 3 drops of acid. 1, 2, 3. You can see the pH increases. So we went from like a 6 to a 7 over there on the left. And on the right, it's kind of still we're at pH 6, yeah? Let's add a few more drops over here. Interesting. All right. I can't see the comments. I've got something screwed up here. I don't know if you guys are commenting or not. There we go. Let's see if I can see the messages coming through. Let's see all messages. There we go. All right. I just figured out how to do it. Forgive me. I'm kind of new to lives here on YouTube. Here we go. I'm adding base over here on the left. And then we'll go ahead and we're going to add base on the right as well. But I'm going to turn the spinner off for a bit here. So here we go. Add some base. What's kind of neat is when you turn off the spin, the stir bar, the solution doesn't homogenize immediately. And because of that, you can get regions of wildly different pH values that persist. Just kind of cool. So yeah, right now we've got, what's that? Like a pH 10 and a pH 6 all in the same flask. Let's add some acid just for the heck of it. So over here, hydrochloric acid. You should see some red develop. You can start to see the swirls of red down the middle. It's kind of cool, huh? Kind of beautiful. All right, I'm going to turn this one off over here on the left. I'm going to add a bunch of acid over here on the left. See what kind of pH we can develop over there. Look at that. You got like the whole rainbow growing on in there. Isn't that cool? It's beautiful. Very pretty. Look at that. We got that rainbow action going over there on the left. So yeah, what's interesting about this is because pH works in powers of 10. Notice you've got like red at the top and violet at the bottom. Red is a pH of 3, violet's a pH of 10. That's a difference of 7, of course. But because the pH scale goes by powers of 10, you know, the acidity, that's a difference in acidity of 10 times 10, 7 times. So there's regions in here that have, you know, a difference in basically acid concentration of 10 million times. You know, 10 times 10, 7 times. It's kind of cool. It's gorgeous. I'm going to get this one spinning. We got to get a little blue over here on the right, don't we? Let's add some base. Let's add some base. There we go. Give it a little spin. Get that going. Oh, knocked the stir bar out of orbit. There we go. Try getting her going again. There we go. For crying out loud, sometimes this thing just doesn't want to behave. I think this might do it here. We got a pH 8 though, yeah? Nice aqua color. I'm going to add some acid to this flask. You might notice that the material stays... How you doing there, dang JOS? You might notice that the material stays in the center of the vortex. The solution, JOS, is water, to which universal indicator has been added. Universal indicator is also known as rainbow indicator, and it displays different colors. Hello there, Henry. It displays different colors depending upon pH. And pH just tells you how acidic or basic something is. So pH is 7. That's going to be neutral. How you doing there, Caleb? Below pH 7, that's going to be acidic. Above pH 7, that's going to be, above pH 7, that's going to be basic. How you doing there, Nathan? Good to see you around. Let's add some base over here on the right. Oh, no, that's not base, that's acid. I told you the wrong thing. How you doing there, Henry? 3539? I love the tornado effect, too. You know, something that's, hi there, Tyler. Something that's kind of interesting and actually relates to, I have my background from the University of Michigan, Marcus. Henry, good to have you on board. Let me tell you something here that's kind of related to the hurricane that's going on. Let me get some acid added here. So over here on this side, actually, it's probably going to work better over here. Let's add it over here. So on this side over here, I'm going to add some sodium hydroxide base, which is going to increase the pH. So right now we're at yellow. But watch what happens when I add. I'm going to turn the speed down just a bit. I'm going to add some base. So in it goes. Try to get it to it persists. Here we go. So I want you to notice, you see that blue color that's added? That's, you know, changing the pH to basic. You might notice that the material stays focused in the center. See if we get it over here too. You see that? I'm over here on the right now. I'm adding it. As I'm adding the... So long there, Nathan. As I'm adding the sodium hydroxide base, you see that blue color. It kind of stays there in the middle. And you might ask, well, why does it do that? Well, it does that because in a flow system like what we have here, on the outside, where the fluid is moving faster, you actually have a high pressure system. And in here in the middle, there's a low pressure system. So right down the center of the vortex, it's low pressure. And you know, just like the eye of a hurricane is low pressure, the eye of this vortex is also low pressure. And of course, material, yeah, I'd say about pH 7. Yeah, pH 8. You're right, Tyler. And material tends to move from high pressure to low pressure. So since that base material that I've added is in the center of the vortex and that's low pressure, it's not going to move anywhere. It's not going to move out. Thank you there, Henry. So yeah, we're kind of seeing the eye of the vortex, the low pressure region. Appreciate the sub. Yeah, if you notice, we're getting kind of close to 500,000 subscribers, folks. So if you haven't subscribed, consider doing so. Consider, sharing some of these chemistry videos that I like to put out. I don't normally do lives, but I'm starting to just because I think it's kind of fun. It's fun to do live experiments. They are pretty colors, man. Keeps your ADHD hooked. Viking 3. Yes, indeed. Yes, indeed. Looks like nighttime, huh? Let's make it sunrise. So I'm going to add some acid over here on the right. The acid I'm adding is hydrochloric acid. It's the same acid that's in your stomach, except this stuff, let's relax. I'll answer you in a second. This stuff that I'm adding is like 100 to 1,000 times more concentrated than the acid in your stomach, thus the glove. So, are the speeds different? They are. You can check the speeds down here. You can see that this one's turned to about 1/3 of the way up. This one over here is almost half the way up. Also, the different sizes of the vortex are because the stir bars that I have are different sizes. Yeah, I like soccer. I like soccer okay. I don't watch it as much. Maybe the surface effect slows down near the surface of the glass. Could be. 5:42 and you haven't fallen asleep. That's rough, man. JOS, you're saying the fastest should be somewhere in the middle. So you're saying the speed should be fastest in the middle. If I had it on the outside, would it disperse quicker? Asks Giange. I'm sorry I'm not saying your name right. Let's find out over here, okay? Over here on the right, I'm going to add drops of acid on the edge. So that's 4 drops. And it does indeed looks like it's dispersing quicker. Yeah, I've had an accident in my lab, Benny. Who discovered the periodic table? Mendeleev, baby. Come on now. So if you're late to the party here, let me explain what's going on. In both of these flasks, I have some universal indicator. Universal indicator is an acid-base indicator. That just means it's something that changes color depending upon pH or how acidic or basic something is. Base 10, you got it, Viking 3. So I'm going to go ahead and add a bunch of base over here on the right. And you can see as I do that, the color shifts to blue and violet. Middle as in halfway between the edge of the glass and the center. You got it, dang. Let me explain this first. So notice I added a bunch of base and the color went to violet. So we see a pH of 10. That's very basic. Okay? So pH 10 is highly basic or alkaline. And now I'm going to do the opposite. I'm going to add acid to this flask over here. So I'm going to do it right at the middle between the outside and the inside as suggested by DOS. And it does look like it's dispersing. But as I'm adding acid, you'll notice that we went from a pH 10 to a pH of 7. In fact, I've added enough acid to neutralize the base. We're at neutral pH. Now watch what happens as I continue to add acid. So here I go. I'm continuing to add drops of acid. And we've gone from neutral now to an acidic solution. It's slightly acidic. It's yellow in color. pH 6. If it's neutral, is it drinkable? Asks Jeremy. Well, technically it's salt water, right? Here, I'll show you. So here's the reaction that happens. Here's the reaction that happens. Sodium hydroxide reacts with hydrochloric acid, and you get water and you get salt. Now, if they're perfectly balanced, then yes, it would just be salt water. However, here's the issue. The indicator that I've added, it's actually a mixture of compounds, and one of them happens to be a laxative. So drop the emoji in the chat that answers the question why this is not drinkable at pH 7. Make it go to red. You got it, Christopher. I'm going to add a bunch of acid over here on the, and I wouldn't trust it's balanced either, JOS. So I'm adding a bunch of acid over here on the right. And you can see that nice red color grow in as we get down to pH 3. Now you'll notice the pH scale here doesn't go below 3. You got it, Dazzy. Dazzy 404, you got it. So you'll notice here the pH scale only goes to 3. That's because from pH 3 and below, it stays red, and pH 10 and above it stays violet. I love me some science too there, Nick. Have I ever hurt myself with an accident in the lab? I have. I indeed have. I mean, there's some common lab injuries you get, like cutting yourself with glass or burning yourself on a hot plate. Those are actually the most common lab injuries, are burns on a hot plate or cutting yourself with glass. But I also did an experiment once that I think actually gave me cataracts. So that could be, Ahmad. The color change magnitude is more sensitive to the acid than the base. That could be because the concentrations of the acid and the base are different. What are some compounds that are conductive? So there's a lot of iron-based compounds that are conductive. If we add the base to the acid, will it neutralize? It will. It sure will. Sounds like a skill issue. So what we did, this is what happened when I gave myself cataracts. I'm not sure I did. Henry, my favorite experiments, whichever one I'm doing at the time. So let me tell you, it's all right. I don't care, Andre. It's fine. It's really, I've got thick skin, man. I know there's chemists out there with a lot more skill than I. So here's what happened. I like to do a lot of goofy experiments, and I saw this one experiment where, now listen carefully so you don't hurt yourself, all right? I saw this experiment where somebody put a light bulb in a microwave, and they turned the microwave on, and the light bulb got bright. However, listen to this. What they did, this is one of those old-fashioned incandescent light bulbs. What they did when they did this is they had a beaker, and they put the conductive part of the light bulb down into the water in the beaker. So there's water in the beaker, and they put it in that way, and the light bulb came up this way. And that was to prevent basically what I saw. So when you do this, it actually, it lights up the light bulb when you turn on the microwave. Again, if you're going to do this, make sure you immerse the light bulb in some water. Well, I saw this, and I'm like, well, man, if it works with the, if it works with the light bulb in the water, with the nose of the light bulb in the water, just think how much better it'll work if you don't stick it in the water. Well, that was a really dumb idea. So, I turned the light bulb on, or excuse me, the microwave on with the light bulb in there. Hey, thank you there, Andre. I appreciate that. Appreciate the sub. And it was the brightest thing I've ever seen in my life, and my left eye really started hurting. I mean, really bad. I thought I had burned my retina, went to the eye doctor, and that's what the eye doctor told me I had done. But a little later on, I went to another eye doctor who said, you didn't burn your retina, which is really good because that would be, basically like solar retinopathy, which is something you really don't want because that's unfixable. They said, I think what you've done is you've given yourself cataracts. Because I noticed my vision started to change after the event. And I imagine there was enough light that was given off that my cataracts were somehow, the lens on my left eye was clouded over. That's something, man. And then a few years later, my right eye went. So I'm a 56-year-old man, and I've had both lenses replaced. Yes, it got more blurry. I don't know what I said. I may have said something stupid. Homemade cataracts. Come on, man. Homemade cataracts. Oh, it's not something you want to do. It is not something you want to do. So, yeah, that's probably the worst lab accident that happened to me. I mean, I've had accidents, but that's one where, there was an issue happened. I'm adding base to both sides right now. Yep, I am better, which was kind of nice. It's all right, Victor. Oh, yeah. So, JOS, what was it, like a high wattage laser? Here, I'm going to turn this one off. I'm going to turn this side off. What am I doing? Timotheus. I'm sorry I'm not... Hey, Brandy. Okay, Brandy and Timotheus. I'm sorry if I'm not saying your names right. Here's what's going on in this live. I have two flasks, obviously. They're on magnetic stir plates. This one is actively stirring. This one is not. To both flasks, I have added some universal indicator. To the flask on the left, I'm currently adding acid. Now, what universal indicator is, it's an acid-base indicator, which means it's something that changes color depending upon pH. So if you look here, you can see the different colors that will be displayed. What happens after red, Henry? It just stays red. So you see the different colors that will be displayed at the different pH values. pH is a way that chemists talk about how acidic or basic something is. The lower the pH, the more acidic it is. The higher the pH, the more alkaline it is, the less acidic it is. Over here, this one's neutral, pH 7. It's neither acidic nor basic. So I got a message here. All right. Supposed to be 5 milliwatt. Interesting. The left is beautiful, Curly. I'm agreeing with you. I am totally agreeing with you. Let's add a little bit of bass over here on the right. Gonna add some bass over here. The left is indeed pretty. I love how that happens. Now it looks like we got nighttime over there on the right. I'm gonna add some acid. Why does the left do that, asks Nick Canty. So that's correct. It is not mixing over here on the left. And because of that, the solution doesn't immediately homogenize, which means the acid and base that I have added, it's going to take some time for that to react. And so you can, in this case, you can get regions of different pH values that persist for a long time. In the mixed solution, here I'm adding acid over here on the left, you might see flashes of this behavior, but because the solution's being mixed so quickly, it does not take long for the colors to change. Is there a limit to how much you can add before it doesn't react anymore? Yeah, at pH 3 and below, the indicators will stay red. At pH 10 and above, the indicators will stay violet. Can you switch them back and forth between red and purple? Andre, let's find out. So we're going to go ahead and see if Andre is correct, that we can switch these back and forth between red and purple. Over here on the right, I'm going to add a bunch of base, and that's going to change the color to purple. Here we go. And then we're going to go ahead and add a bunch of acid, which should neutralize indefinitely. Ask Andre. We're going to find out here, bud. I'm adding a bunch of acid. At some point, it should neutralize when it hits green. So it's getting neutral. And as I continue to add acid, we are going to see it turn acidic. pH 3. There we go. We're already to red. And to see if we can switch it back to base. Thank you, Viking 3. We're going to add base now. And we're at neutral. Actually, we got a little rainbow action going on, which is always kind of fun. So, Andre, I agree, JOS. I need to get some dry ice for this experiment at some point. So, to answer your question, Andre, after the live is over, what I do is I first acidify them, because I've learned as long as the solutions are pH 3, mold doesn't grow in them. And I just save them and I reuse them. I've been using these over and over and over again. If I leave it at like pH 8 or 9, I've noticed that mold tends to grow in the solutions, and then, I got to rinse them out. Thank you there, Viking 3. Appreciate that. Is your name short for Viking, as in Minnesota Vikings? If so, I've got some colors for you, bud. I got some colors for you might enjoy. So I'm going to turn the stir bar on over on this side, and we're going to get everything all mixed up, get it homogenized. And over here on the on the right, we're going to turn off the stir bar, and we're going to add some hydrochloric acid over here on the right. It's kind of like daylight breaking through the night, or like a sunset. Look at that. Come on, baby. Come on, baby. That's cool. What's the best thing I've ever done in my lab? Benny, I'm not sure exactly what you're asking. If you're asking in terms of I would just suppose teach other human beings. I think that's the best thing I've done in my lab is to teach other human beings and to learn from other human beings. For me, that's the coolest thing I've ever done in my lab. Now, if you're asking the coolest science thing I've ever done in my lab, wow. Hey, thank you there, Brandy. What's the coolest science thing I've ever done in my lab? It's so hard to say because I've done so many interesting things. One of the coolest things we've done is make a Rubens tube. I don't know if you know what a Rubens tube is. If you don't, just Google it, man. Google it right here on YouTube. Check. I've got a video on a Rubens tube here on my channel. It's a flame tube that helps you. It's a flame tube that helps you visualize sound. It's very cool. There is no difference what acid you add. Ramsidius. It would matter what acid I add. If I end up adding say, for example, a weak acid and then add a strong base, we would end up buffering the system, and that would make it tough to make the color changes. Could I purify the water with acid, then neutralize it to make it safe to drink? Asks Andre. I could, but here's the issue. The indicator that I add, it has 4 different dyes, and one of them used to be the main ingredient in X-Lax. So Z717, I'm adding 20% by weight hydrochloric acid and 20% by weight sodium hydroxide, and that seems to work well with the color changes. Yes, I would say if you could perfectly balance the sodium hydroxide and the hydrochloric acid and get them perfectly neutralized, you'd be drinking salt water. Yeah, the purple does tend to be towards the bottom, but here, let's try it the opposite. So this started with purple. So I'm going to get this all mixed up over here on the right, and then what we're going to do is we're going to make it red to begin with. So I'm going to add a bunch of acid over here to make this acidic. For some reason, my acid does not seem that concentrated. Okay, we've got this acidic. Now I'm going to turn it off. And now I'm going to add base to this. And my guess is that we're now going to see the red on the bottom because we reversed the way that we did this. So in goes the base. I'm at a bunch. There we go. All right. I have done a BZ reaction. I've got a video on it. I bet you know what sodium hydroxide is, but I don't know the composition of a chocolate chip cookie. Come on, man. Oh, man. I guess you're right. I mean, I don't know everything that's in a chocolate chip cookie. It does look like an interesting drink. Does the purple lower so yes, the violet means it's alkaline, Nick, or basic. Here in the United States, we use the terms alkaline and basic as synonymous. How strong is the acid I'm adding, Timotheus? It is 20% by weight. 20% by weight hydrochloric acid, 20% by weight hydrochloric acid, 20% by weight sodium hydroxide. Mix them. So, Kayla, you want me to mix this with this. Is that what you're saying? Oh, we can try that if you want. It'd be fun to do it this way, though. Let's get one of them red. And the other one, so I'm going to make this one red over here. You're a high school chem teacher. Are you using phenolphthalein as the indicator? I am using universal indicator. If you don't have some of this, you should really get some. So I'm using universal indicator. You can see I got it here from Ward Scientific, so you should be able to get some of that. You can also buy it from Flynn Scientific. In my opinion, every chemistry teacher should have some universal indicator. There's a wide variety of experiments you can do with that. How does it change color based on acidities? 20% HCl would be less than pH 0. That's right, Dang. I'd have to do the calculation. I can't quite do it in my head, but I'm almost certain it would be negative pH. So how's it the color change based on acidity? Here's what we're going to do. That's a theoretical question. We're going to just focus on one of the dyes that's contained in here, okay? Less than 0. So the higher the acidity, the lower the pH goes. So we're going to think about phenolphthalein. So phenolphthalein, if I had this in here, most fun experiment, creative. Ask that again in a little bit, okay? I'm not making mercury fulminate. Not happening. I don't mess with mercury compounds. So let's look at this particular indicator right here, okay? As I'm explaining, forgive me, I got to stop reading the comments for a bit. This is going to take some brain power that I've got to focus on. So one of the compounds in universal indicators called phenolphthalein. And phenolphthalein is a ring-shaped molecule. And when it has a proton, we're going to imagine this white thing here is a proton, okay? And when it grabs onto a proton, so to speak, the phenolphthalein molecule has a ring shaped like this. And when it's shaped like this, it's colorless. Now, if you add a base to a collection of phenolphthalein molecules, bases accept protons. So the base will come around and it'll take that proton away from the phenolphthalein molecules. And when that happens, the structure of the phenolphthalein goes boop, it pops open like that. And with that change in structure comes a change in color. And that's why at the higher pH values, you see a shift to a color. Now, what happens when you add acid? Acids are proton donors. So you got a bunch of molecules like this. You have a bunch of acids that they give these protons. And if there's a bunch of these around, then the phenolphthalein can grab onto them and go back to colorless. That's, in general, the way indicators work. You're a 6th grade student, hoping to either be a doctor or marine biologist. Cool to hear, man. Cool to hear. Love it. Keep studying your math and science. Somebody asked me what is one of the most interesting experiments I've ever done. Here, let me tell you about this one. What we did, and I continue to push this particular experiment. You can see it on one of my videos. We recently redid it. So one of my favorite experiments to study, I've actually published articles on this, believe it or not, is a Diet Coke and Mentos experiment. And through my studies, I learned that pressure, atmospheric pressure, actually affects the reaction. I learned this by reading through a bunch of articles on how bubbles form in champagne. Anyway, by reading through these articles, I learned that, lo and behold, bubble nucleation is what they call it. That just means, how bubbles form. Bubble nucleation is affected by atmospheric pressure. And it's the case that when you go to lower atmospheric pressures, the bubbles form easier. They nucleate much more quickly. And that gave me the idea that, as you go up in the atmosphere, certainly the pressure drops. The atmospheric pressure drops. So that gave me an idea. Hey, let's climb a mountain. And as we climb a mountain, let's do the Coke and Mentos experiment all the way up. Somebody wants me to turn the speed up. And so we did that. We actually did that. We did the Coke and Mentos experiment while climbing up a mountain. And if you want to check out my videos here, you can see what happened. You can probably guess what happened, but nevertheless, that was one of the coolest things I remember doing. The one thing I had a problem with when I was learning water chemistry was the difference between alkalinity and pH. I think alkalinity has a kind of weird definition, like a specific chemical definition. pH, that's just simply the concentration of protons. It's just a way of mathematically expressing the concentration of protons. You may have learned hydronium ion. So the pH is the negative log base 10 of the proton concentration, or the negative log base 10 of the proton concentration. Easier start to the bubble at higher altitude. That sure is the case. We saw the Coke and Mentos experiment got much higher on top of Pikes Peak. That's the highest I've done it. What will happen if I take a bottle of tert-butyl lithium and smash it on the ground? That's not an experiment that I want to try. Hey, I think we're there. I got the Tiger colors, the Detroit Tigers. Hello, Henry. I was watching the Tiger game, and I got a little too nervous, and I thought, you know what? I don't want to be that nervous. I'm going to go downstairs and do a live for people. So if somebody wants to drop in the chat the score of the Tigers game, I'm probably going to be disappointed. But let me know. Did the Tigers beat I almost said their old name. Did the Tigers beat the Cleveland Guardians? Or the Cleveland Guardians beat the Tigers? Or are they still going? Let me know the score. Thank you there, Sam Colo. I don't mess with mercury compounds, Kion, so I don't know. I do not mess with mercury. I'm kind of careful. I'm adding acid over here to the flask on the left. Hey, Nacer, thanks for hanging out. I appreciate you hanging out with us. Abdul wants me to mix them. All right, let's try that. Hold on. Let me get this one to be... Let me get this side to be basic. The Tigers won 3-zip. You got to be kidding me. Come on, Agape. Come on. Tell me you're not kidding me, Agape. That would be like really mean. Come on, y'all. Did the Tigers win? Cannot believe it. Oh, Finn's telling me he was messing with, not messing, but had a mercury thermometer broke. Those things are a mess. They took the W, Nathan. Come on, that's awesome. That's awesome. Thank you, Agape. Thanks for letting me know, y'all. That's just crazy. Yeah, I stopped watching in the 8th inning. I don't know who was watching the game, but if you're watching the game, when that one outfielder from the Guardians, Tigers had 2 men on, had a beautiful hit to the outfield, and the guy just barely caught it. I was so upset. Thank you there, Jay. Okay, somebody asked me, what happens? Tigers all the way, Nathan. Come on, buddy. My day's great now, master. Yeah, I'm in Michigan, Charlotte. Okay, somebody asked me, what happens when we mix these two together? Well, if you've been paying attention, you should know. Drop me the heart emoji in the chat that will describe what should happen when we mix these two together. Come on, Henry. Come on, buddy. We see you there. I'm gonna have to block you here if you keep spamming the comments. We see you, buddy. We see you. All right, here we go. How does hydroxide come into play with the power of hydrogen? So it works like this. Here, let me put this little beaker here first because we're going to mix some of these together, okay? It works like this. The concentration of hydroxide times multiplied by the concentration of hydronium or protons. If you take that product, it will always be 1 times 10 to the negative power of 14 at room temperature. That's how it works. Supposed to go 7, but you're betting on 6, says Zumbi. Dang JOS, says Green Heart. KW, Hurtful Steam. The chemist has entered the chat. Charlotte, I say both. I went to Michigan. My sons went to Michigan State, so I really don't care. Why did the acid have a significantly bigger whirlpool? Look, different size stir bars and also different speeds. Okay, so somebody asked what happens when we mix these. Let's find out. Give me a second. I got to find I don't know. Here. I'm going to try to make this as even as I can. All right? So here we go. I'm trying not to make a mess. Squirting them together. So I'm just taking a little out of both, and we're going to squirt them both in there. I don't know if you can see the color yet. I'm going to do it like 4 or 5 times. Wait, I didn't learn that in elementary school. I didn't learn that you make green by mixing red and violet. I learned you made green by mixing blue and yellow. What the heck's going on? Well, if you've been paying attention, you know the drill, right? We know why that went green. Because over here, I have an acid. Over here, I have a base. It just happened to work out that they look fairly well balanced because when I add equal volumes of them, they neutralize each other. See, here's our pH scale. Man, that worked beautifully. See that? There's a pH scale. Yeah, you could do this experiment with parent or adult supervision. You sure could. However, I would recommend you do it with red cabbage extract. So what you do is you just boil some red cabbage. And when you boil red cabbage, you're going to get an acid-base indicator. It's just going to show these colors. So red cabbage will show these colors. Thank you there, Nathan. I appreciate the kind words. What acid and base do I have? Asked Finn Jones. So the acid that I'm adding is hydrochloric acid, 20% by weight. The base that I'm adding is Did I say hydrochloric acid 20% by weight? Yeah, and the base I'm adding is 20% by weight sodium hydroxide. So that's what I'm adding. The indicator that I'm adding is universal indicator. No, they're strong acids, Modern Orca. That's correct there, Jay. Jay is a new chemist who's entered the chat. How do you do this experiment with red cabbage? Kion, what you'll do is you'll boil some red cabbage. You'll get a violet colored solution. It might be red, it might be, blue, depending upon conditions. And then what you do is, say you wanted to make it red, you're going to add some vinegar. Vinegar is an acid. If you want to make it blue, you can add some baking soda. Baking soda is a slight base. If you want to make it green, you're going to add some ammonia, which is a fairly good base. Hey, thank you there, Master Pilot. Come on, America. Look at that. Somebody just sent me a gift with some money. That's really nice. Come on. What's the percentage difference in moles of the two if you made it by weight? Nick, I can't do that calculation in my head when I'm doing a live. I'm gonna keep the conversation going if I stop to calculate. America, I appreciate it. Thank you very, very much. That's a very, very kind gesture. I do not have a weak acid ? I'm adding hydrochloric acid, which is a strong acid. Forbidden Kool-Aid, says Nathan. I love it, dang JOS. Thank you, America. I hope to see you in my comments. I'm going to see if I can figure out how to block that guy. Come on. Get him out of there. Let's see. Remove. Maybe it's just... Oh, I can only delete the message. Put user in timeout. Okay. Henry, I'm going to put you in timeout. I have that. I have the power. Come on, Henry. Don't make me do that. Don't make me put you in timeout. I prefer not to. I'm going to give you a chance here. All right. Hannah, I have used bromothymol blue. Jay, thank you. Appreciate that. Appreciate that. Don't sweat it there, Henry. Just do better, okay? Thank you. Am I switching between acid and base to the solutions to change their color? You got it. You got it. Hello there, Andrew. Goat, the naughty corner. Yeah, maybe a bot, huh? Thank you there, Mr. Giggles. Appreciate that. If you neutralize and drink, will you? Yes, I will, typical, because one of the dyes is a laxative. Left solution looks like the inside of a kiwi. I love it. Now add metal like zinc and see if it makes a pop sound. Thank you there, Jay. I appreciate that. Come on, that's awesome. Consider sharing the channel. We're getting pretty close to half a million subscribers, which is been working pretty hard at that. Thank you there, Joshua. Tell me, you do high school science. Tell me what classes you teach. Thank you there, Razor. Appreciate it. A little lithium foil never killed anyone. Yeah, typical. I do some experiments with lithium batteries. Can I try phenolphthalein? Unfortunately, I don't have any with me, but you should know that one of the indicators in Universal Indicator is phenolphthalein. Of course I did, Razor. Come on now. You commenting? I wanna talk with you all. That's what it's all about. What do you think of those stirrers? I do a reaction that is a slurry, and my mixer slows way down. I don't know, man. I don't know if this is going to do a good job of, keeping things from, from getting gummed up, so to speak. Nice to hear there, Razor. Low potassium is a treat. Come on, man. Yeah, it's nasty, America. I don't mess with the lithium foil from batteries. I use, the coin batteries. Actually, I think my next video I got coming out, my next short video that I got coming out on Saturday deals with this. So I get the lithium out of a battery and I pop it in some water and we make some hydrogen gas and we ignite the bubbles. It's kind of fun. Nothing special, but fun enough. All right, where in the world? I'm running out of acid. I got to replenish here. And I've got a funnel somewhere that helps me. There it is. Okay, you got to forgive me here for a second. I got 2 neutral solutions, but I've got to get some, I've got to replenish my acid bottle here. I think that ruined your weekend or ruined your day there. All right, give me a second here. I'm going to refill my acid bottle. Checking out the comments here. Yes, that's correct, Andrew. It might look yummy, but it's not going to feel yummy. One of the indicator dies. Hey, A-Normal. How are things in Florida? I hope you're not in the path of any vortices, atmospheric vortices. Do I follow ice hockey? Viking? I don't. Absolutely, Razor. Pure potassium can indeed cause an explosion when it touches water. What happens is the potassium reacts with the water and it forms hydrogen gas. And if that hydrogen gas gets hot enough, it will react with oxygen in the atmosphere, and it does so explosively, forming water. Okay, it is a little relaxing. Okay, what we're going to do now is I'm gonna show you something here that relates to the hurricane that's unfortunately passing over Florida, or getting ready to. So I want you to notice that this is a vortex here, and in a sense, a hurricane is an atmospheric vortex. And you may have remembered that, you know, a hurricane, the eye of a hurricane, is a low pressure system. And we can show that here because this is a vortex, and the center, the eye of this vortex, is a low pressure system. I'm going to add a bunch of base here. So I'm going to add drops of base, and you can see that it kind of stays in the center. You see that? The material stays in the center. I can see it because that's where the blue stuff is. Now, of course, it gets to the bottom, and it gets pushed down around the sides. I'll do it over here on this side, too. I mean, it's not a perfect system because it's kind of small. But we can imagine, you know, imagine an infinite bath of water around this. We wouldn't have to worry about the stuff going down the sides. But notice when I first add the material, it pretty much stays in the center. And the reason why it does that is because the center has low pressure. The center of the vortex is a low pressure system. And material moves from high pressure to low pressure. And so the material that I'm adding, since it's in the center, it's in a low pressure region, it's going to tend to stay there. So you see I've added acid. I'm adding acid to the center here. And you can see that red line kind of stays there. You know, again, until it hits the bottom and gets pushed out along the sides. I agree, Goat. I think if you use this system, it would be great for like a bartender to use. That's all right. You don't have to remember this. Part of what we're doing is just having fun. Part of it's enjoying some science, too. Some folks may pick up some science. Some folks won't. Oh, nice. How long have we been going? We've been going about 46 minutes. I do too, Razormouth. What makes the tornado? So what makes it here? I'm going to turn this off. So there's a little, see that down there? There's a stir bar. That's just a magnet. And it's sitting on this thing. This is like a fan with magnetic blades inside the box. And when I turn this knob, it makes the fan spin. And of course, when the fan spins, it makes the stir bar spin. So Ruchi just joined us. What if you add acid or base to the edge? I'll find out here. How come if they were both green and you add the same blue chemical, why were they 2 different shades of blue? So it's going to, okay, lots of questions coming through. Let's start from the beginning. Let's start from the beginning and talk about what's in these flasks, okay? So what's in this flask and what's in this flask is the same thing. They both have water, and they both have added to it some universal indicator. Universal indicator is also known as rainbow indicator. It's an acid-base indicator that changes color depending upon pH, which is how acidic or basic something is, okay? So you can see this flask over here is neutral because it's green, and that green tells us it's pH 7. pH 7 on the pH scale, that's neutral. Over here in this flask, it's yellow, so that tells us it's pH 6. Now watch what happens when I start adding some acid to the flask over here on the right. You can see it up here at the top. I'm starting to add acid, and you see the red color develop in the center of the vortex where the acid gets added. It tends to stay in the center because that's a low pressure region, just like the eye of a hurricane's low pressure. But once that starts to get homogenized through the solution, we see that that yellow color changes to red. So we see upon addition of acid, the pH drops. Water is pH 7. That's correct. That is correct. Now, over here on this side, instead of adding acid, I'm going to add base. So here we go. Over here on this side, I'm going to add some base. The base I'm adding, by the way, here in the United States, we use the term alkali and base synonymously. So I've added a couple drops of base, and you see the pH rises. What's up, Razor Mouth? So yeah, that's all we're doing. That is all we're doing. Big brain. Tell me what you love about science classes. I agree, man. The magnet mixing is, you got it, typical water. People tend not to like drinking pH 10 fluid. What is the most rare chemical? Probably the most rare element, if I remember correctly, it's going to be, well, okay. I mean, you know, any of the more recently discovered ones like organoson, element number 118. But the one that is naturally found on Earth, that's fairly rare. Things like francium would be very rare. The pH 10 is not acid. So camel. So here's the way this works. A base is the chemical opposite of an acid. A base is a chemical opposite of an acid. They are both corrosive, and they can both do some nasty stuff to your skin and your bones and your body, okay, and to metals. So they're very reactive materials. But what they do when they meet each other, acids and bases react with each other and they neutralize each other. So the acid neutralizes the basic properties of the base, and the base neutralizes the acidic properties of the acid. Oh, yeah. I mean, acid can kill stuff for sure. Absolutely. I mean, if you had it strong and concentrated enough, you know, you wouldn't want to fall and say into a vat of concentrated sulfuric acid or concentrated hydrochloric acid. Oh, equilibrium's awesome, Ruchi. I'm glad to hear it. Tommy Technetium titrating tremendously. Andrew Bell, that wins a Tommy Technetium Silver Comment Award. Wonder if I can reply to that. Here we go. Can I reply? I can't. At least I don't know how to. Especially not sulfuric mixed with peroxide. You got it, dang. I have a video out where I put a scrub daddy in that mixture. You might want to go check out my videos. It's kind of fun to see. You use a CO2 extinguisher to make dry ice. That's cool. And isopropyl alcohol to freeze gas in high school. And the teacher was interested. I love it. I love it, big brain. pH scale goes from pH 1 to pH 14. Paris, that's right. That's traditionally the way that it's shown. What's interesting is the pH scale can actually go below 1 and go above 14 in some extreme cases. Kion, make sure to drop me a comment somewhere in one of my videos and let me know if you all do that. I'd love to hear about it. What's the next stream going to be about? Well, you know what? I tend to do the same thing for my live streams. However, I'd like to hear from you if you all think that's a good idea or not. Should I continue to do this particular experiment for my live streams, or should I try doing new things every time? Oh, nice to hear, Ruchi. Why does sulfur smell horrible? That's a great question. I don't know. Anyone know? Why does sulfur smell so bad? New things would be cool, says Dang JOS. All right, there's a vote for that. Definitely more things but simple stuff, says Big Brain. I tell you what, I'm not going to tell you what it is because I don't want to get scooped. but I have a new experiment coming out. I guess it's not new. I've seen other creators do it, but I've not seen other creators. You want to build a small fountain, a gallon stand. I've seen other creators do this experiment, but I've not seen anyone actually explain the phenomena that's occurring. And I don't think I have it coming out as a short this weekend, but next weekend I'm going to be doing a really simple experiment that is absolutely gorgeous. It's something you can do in your kitchen and not, you don't have to worry about safety or anything. And you can just see some really gorgeous results. And then within a 1 minute short, you can't go into great detail in a 1 minute short, but I give you enough information to get a good feel for the phenomena that's happening. Thank you there, Big Brain. Look at that bubble vibrating on the right. Come on! Oh, thanks for pointing that out. Check it out. That does happen. I like to call these floaters. You see it there? So there are bubbles that sometimes get trapped in the middle. So what's interesting about this is this helps us see that remember I told you the middle is a low pressure system. And we can tell that because that bubble is stuck in there. It's not able to get pushed out because it's high pressure on the outside, low pressure on the inside. So the high pressure just keeps it right in there. And you can totally see that. Thank you for pointing that out. I did hear that, Avery. We're going to be able to get to go into 3 minute shorts. Let me talk about that. That's a question I have. I did hear that we are able to get to 3 minute shorts, but I'm telling you what, I'm wondering. I mean, people tend not to, when you're on your cell phone and you're watching shorts, people tend not to get drawn into longer videos. People do tend to like you to say what you need to say in a minute or less. I'd like to hear what you all think about that. Do you think it'd be a good idea to try to push my short form, the short form that are vertical, my vertical videos to a little bit longer or what? Sorry to hear that, Razor. If you put back pH 7, the yellow one, can we drink it? You could, but you're going to be on the toilet for a while because one of the dyes in here is a laxative. Thank you there, Kion. Though odorless in its normal state, utility companies add sulfur-containing odorants called mercaptans or thiols to like butane. You'd watch longer shorts as America? Some people would stick around, but not as many, says Dang. Do I mind if you spam the live with hearts? I don't really know what you mean there. I'm going to go get some sleep. I hope so, Jay. Have a good evening. Yeah, I know. Isn't that the trick, Viking? It depends, right? I mean, see, I started my YouTube channel in like 2013, and it didn't do very well because, I'm a chemist and I like to go into great detail in what's happening in different phenomena. And, the channel didn't do well. And when YouTube Shorts came out, my channel took off because people don't want to listen to me for more than a minute. Happy birthday there, Leandro. If it's neutral, you said it was salt water, but if you boil it, it would be pure water. So Avery, if I took this here and I boiled it, what would happen is the water would boil off. The salt that was in here would precipitate out on the bottom as a crystal, and the dye would also be there as well. Ooh, you do your shorts in 2 or 3 parts and put links for all of them. What are the different pHs about? Can you break it down? Sure, Kion. Here's the way this works. So the pH, it's a simple way to mathematically describe the concentration of protons in a solution. So here, let me write this equation down. See here. Oh boy. So this entity here, H plus, this is what we chemists think of is when we're talking about protons. It's a hydrogen atom with a positive charge. We call that the proton. And this is what acids donate. Now, when we write this thing here in brackets, what we're saying is the concentration of. So anytime you see brackets, you're saying the concentration of. So the pH deals with the concentration of protons. And it works like this. I'm going to give you the equation here. pH is the minus log base 10 of the proton concentration. I know I'm going to lose some of you here. So that's the equation up there at the top. The pH is the minus log base 10 of the proton concentration. All right? And so it works like this. So if my proton concentration is 0.01, let's say that's what it is. And then units are molarity. We're not going to get into that. All right. So if my proton concentration down there at the bottom is 0.01, I can write this as 10 to the minus 2. 0.01 is the same thing as 10 to the minus 2. And if I pop that 10 to the minus 2 in there, I mean, what you're asking is what is the power of 10 of the proton concentration? That's really what you're asking. What's the power of 10 of the proton concentration? Well, the power of 10 of the proton concentration it's negative 2, but we take the negative for the pH. So the power of 10 of the proton concentrated made negative is 2. And that's it. That's how the pH works. And because of the way it's defined, the lower the pH, the higher the acidity, the more the protons. Yeah, I know, Curly. About 20 people left because I'm talking mathematics. I get it. See, that's what I'm saying. We were having a conversation earlier. We were talking about, people don't like the details, man. People do not like the details. Oh, thank you there, Viking. I love it too, Hurtful, but you know what? Most people like the beauty of it. Hello there, Nearsin. Nezrin. Is there a clear line between the different sciences? Where does chemistry begin and end? Interesting. So, definitions change. What an interesting question. Who is that? I want to see that. I want to make sure I say your name. Andrew, what an interesting philosophical question. So when I first learned chemistry, it was in 1984 in my high school chemistry class. And back then, we learned that the definition of chemistry was the study of matter. That's what it was defined as back then. And so that gives some fairly clear lines for what falls under the umbrella of chemistry. However, over time, when people started to study what they call particle physics, well, particle physics, that's like, you study like electrons and you study quarks and gluons and all that stuff. That's matter as well. But yet they call it particle physics. So the lines got blurred, the definition got blurred. And chemistry actually got changed over the years to the study of basically the materials that are on the periodic table, or the study of materials. So I think the fact that historically we recognize that the definition of various sciences change, I think that tells us that it's just really blurred. Like I once heard a chemist say that chemist is everything from playing with the nucleus of the atom to petting the dog. I would actually expand that further. Because, for example, it goes all the way out to astrophysics. Because, we know, for example, that the sun is made of hydrogen and helium, and we know that because we know about the properties of hydrogen and helium. We know what gas clouds in nebulae are made of because we know the chemistry of the materials that are found in gas clouds. So I would say chemistry can be everything from toying with the nucleus to uncovering the properties and composition of astrophysical objects. Thank you there, Kion. All right, Razor. Hey, folks, what I do at the end of the live, college did I go to learn all this? I went to a lot of different colleges, different branches of chemistry too. So what I do here at the end of the live, folks, is I'm just going to warn you what's happening. We're going to stop the experiments. I'm going to flip the camera. You're going to get to look at my ugly mug. So I'm warning you, you're getting ready to see a 56-year-old man in his basement, okay? So leave now. Now is time to leave if you don't want to see that. But yeah, I'll just read some questions and focus on the comments a little more rather than the experiments. And we're going to flip her around, and then we're going to call it a night. What university am I from right now? I work at a university in thank you there, Dang. I work at a university in the state of Michigan. Thank you there, Phoenix. Thank you there, Big Brain. Appreciate it. Thank you there, Lou. Appreciate that. This is my go-to live where we just do experiments with acid-base indicators. Thank you there, Hurtful. They're readers. Thank you there, Curly. Thanks for being on board. How often do I go live? Enrique, usually about once a week, sometimes a little more. My wife's at yoga tonight, and so I got nervous watching the Tigers game. It was about the 8th inning. I couldn't handle it anymore. I thought, I'm just going to go burn off some steam and do a live. So long, Kion. Thanks for hanging out. So Big Brains from Saginaw, huh? Is there a usual day? Lou, I'm going to have to start doing a usual day. So let's go like Sunday, all right? I'm going to try to do a live on Sundays, but that doesn't mean I'll always do it on Sunday. Hey, Viking 3, so long. Phoenix, let's go for next Sunday, 4 p.m. Sahal, I have a BS ED in chemistry. I have a Master's of Science in chemistry, and I have a PhD in chemistry. Agape from Redford, come on, baby. I'm loving it. Thank you there, SHJ. All right, Lou. Oh, you got a cousin in Saginaw. Nice, big. You're from Saudi Arabia. Very cool. What do I do during lives? I do science experiments. I don't know, man. I don't know. 4 p.m. would probably be about 8 p.m. your time, I'm guessing. Dang, I loved it. I love learning. Go Blue, baby. Go Blue. Have I ever worked with fatty acid vesicles? I've not. You're doing your master's and could, well, let me know what you're doing, Sahil. I mean, I'm a generalist, so I know a little about a lot, I guess I should say. Thank you, Lou. Let me know. Let me know what you think. All right, Phoenix. Give me a shot, Big Brain, but just know I'm not a synthetic chemist, all right? I'm not a synthetic chemist. I'm not going to be able to help you much with that. Let me hear what you got. Let me hear what you got. I'm going to show my father. He was in honors in 3rd grade. Cool. Nice to hear, Kion. That's cool. Yeah, be sure, I always look through all my comments on my other videos. So if you caught alive, make sure you say some of that. You're trying to electroplate 3D printed parts with copper sulfate. Interesting. So are you using just the regular electroplating solutions? Are you using electrolysis, or are you just using like a voltaic cell, Big Brain? 3D printed parts. That's an interesting idea. You're trying to electroplate, I imagine, the copper metal onto the 3D printed part. And I imagine you're probably having trouble with nucleation, Big Brain, would be my guess. That would be my guess. Used a power supply, and you're trying to electroplate the copper onto I'm imagining some kind of polymer substrate from the 3D printer. This would be my guess. That sounds interesting, man. That sounds like fun. Trying to formulate a topical formation based on fatty acid vesicles. You're a pharmacy student, but yeah, great to hear, Sahil. You should be able to, if you know what you're doing, you should be able to find my academic email. Come on, isn't it, Lou? The Venom gallon stand is so cool. Like, that experiment, blows my mind. You coated, so you 3D print, really smart. You 3D printed some object, and you coated it with graphite. I don't know much about that. So is it pretty easy to coat metal or electroplate metals on graphite? What's an experiment anyone can do at home with adult supervision? Diet Coke and Mentos, baby. and it didn't conduct electricity, but you did get it to electroplate onto the graphite coating. Come on, man, I don't believe that. So you're telling me you had some sort of polymer 3D printed structure. Onto that, you somehow spun graphite on it somehow. You got the copper to plate on it, and yet it didn't conduct electricity. Well, that makes me wonder if you coated, like if the copper's oxidizing, is what I'm guessing. Big brain. Unless I don't, I mean, I'm trying to understand what you're doing through a bunch of comments here, which is a little tough. Maybe the copper had a lot of gaps. Polylactic acid as the printer filament. Polylactic acid. Is it polycaprolactone or polylactic acid? I need to write this down. Yeah, we were doing science, Aviator. I tell you what, we're getting a little long here in the tooth with the live big brain. Do a little Googling online. You'll figure out what my academic email is. Send me an email. Yeah, I'm thinking. So, did it have like a blackish color? Because that's that could be copper oxide, but it could also be copper nanoparticles as well. Lots of great questions. I apologize. I'm gonna hit out of here. So it did have a black coating. So my guess is you're either getting copper oxide or you're getting copper nanoparticles, and somehow those copper nanoparticles are forming in individual clusters, like Dang JOS suggested, that is not allowing for conduction. Carbon dioxide candy experiment. Sounds cool, Kion. Hey, thanks for hanging out tonight, folks. I had a great time doing experiments with you. I learned a little bit about some electroplating experiments, which sounds pretty cool. We'll see you next time. And in the meantime, make sure you're looking at the beauty around you, the beauty of science. Man, it's everywhere. Look at those sunsets. Look at those sunrises. Check out the clouds. It's all over the place, man.